everyone. So my name is Raphael Badin, and I'm with Cisco. Sorry?
Yeah.
Oh? No speakers? Hello?
Getting volume on the recording.
Just go ahead and keep going.
Should I continue?
Yeah, go ahead.
Okay.
Just talk loud.
Yeah, I'll try to talk louder then. So today I'm going to talk about the development tooling that we developed as part of the Metapod project. So Metapod is an OpenStack-based on-premises solution by Cisco. I'm not going to be talking about Metapod itself, but mostly the development tooling that we use to develop it. So if you want more information about Metapod itself, you should just look it up and you'll find all the details online. So let's talk about the context a little bit. About 6 months ago, maybe a little bit more, we decided to rewrite most of the automation to deploy Metapod, which again is just a customized version of OpenStack with a particular configuration in terms of how many machines are used for as controllers, how many machines are used as hypervisors. And we decided to change the automation to move to Ansible, which obviously, as you can imagine, was a big move. And as part of this move, we also decided that we needed to be able to stand up dev clusters on demand. And the requirements for this were that we wanted to be able to stand up a cluster with one command, and we wanted it to be as fast as possible to let any developer that wants to do development or testing use that tool. Additionally, we wanted the CI itself to be able to stand up dev clusters in a fully automated fashion. So this is the context. Now I'm going to talk about the design a little bit. Again, without getting too much into the details of Metapod itself. On the top here, you've got the production pipeline. So what happens when we deploy stuff in production, there is the provisioning, bare metal provisioning, then machine configuration, and then that's where Ansible is used, and it's used to deploy the Metapod. And it's using a production inventory. So inventory is just Ansible speak for all the configuration and all the IP addresses of one cluster. So what we wanted to do is to have a similar workflow, but to use it in a dev context. So basically replace the provisioning and the configuration step by something that would be ad hoc and that would be focused on dev environments. But the main benefit that we wanted out of this is to use exactly the same Ansible playbook that we use in production. So the trick was that in the original Metapod design, we use basically two different types of machines. There are the normal machines, the controllers, and the hypervisors, which are RHEL machines. And then we use routers, ASR routers, that do all the layer 3 operations. And things are hooked up using a Neutron plugin. So in the context of a development environment, we wanted to go to a place that doesn't require us to use physical machines, obviously. And so we could use the RHEL cloud images, but we had to obviously replace the ASR by CSR, which is a virtual router that is similar, at least the interface is similar to the ASR. So this is the bit that we developed. Again, we decided to use Ansible to orchestrate everything because it was the platform that we were using for all the rest of the development. And the only thing that we had to add in addition to Ansible was what we decided to call axion, which is just a Python library that does basically the provisioning and the configuration. So let's see what axion does in details. So it does basically two things. As you could see from the previous slide, it does the machine creation and the machine configuration. So this illustrates how the machine configuration works. So before I explain the details here, the main platform that we decided to use is something called Proxmox. I'm not sure if people are familiar with it, but it's just an open source server virtualization environment that is used to simply spin up virtual machines. And I would say that the main benefit of Proxmox is that it's very simple, and yet it can be controlled through an API that covers all the functionalities that are available in Proxmox. So the first step for Axion is to create the machines. And here, Ansible drives Axion in the sense that it generates an Axion config, and we'll see an example of such a config later. It generates the config that describes basically how to access the Proxmox cluster, and also it describes all the nodes that are going to be present in that cluster. So Axion then talks to Proxmox and configures the required machines. That's obviously simply using the Proxmox API, creating the machines and configuring the networking. Because something that I forgot to mention is here between the production and the development pipeline, the most important stuff is that the contract should be exactly the same in order to be able to use the same Ansible playbook. And that contract is basically having machines that run and that are available through SSH. So basically, Axion's goal is to stand up those machines and configure them so that they can be accessed through SSH, and then the rest of the playbook, the actual deployment playbook, can be run. So machine creation, we've seen this. The only trick is that we had to configure Proxmox in such a way that we could configure both RHEL machines and CSR-based machines to act as routers. Then the second step is the virtual machine configuration. And here, it's basically the same workflow. Ansible creates a configuration file, and again, we'll see an example of that later. And Axion talks to Proxmox and does the configuration of the machine. And here, the trick that we used is that Cloud Init supports the different types of ways to send data that Cloud Init will then use to configure the machine. And what we use is the ability for Cloud Init to read that data from a CD that is attached to the virtual machine. So in order to be able to configure those machines so that they can be accessed through SSH, which means having them bring up an interface, configure that interface with the proper IP address. What Axion does is that it bundles that information into Cloud Init's valid file, and it attaches this file as a CD-ROM that will be then picked up by the RHEL instance when it starts. And the same thing can be done for the CSR. In Cisco iOS, there is similar support for reading configuration from a CD-ROM that is attached. So that's something that Axion does. It bundles that information that is configured in the configuration file, and it creates what's needed for the CSR and the RHEL images to be configured when they boot up. So this is what Axion looks like. Like I said, it's a simple Python library that basically takes a configuration file and then creates the VM on Proxmox. It has currently only one provider, and that's Proxmox, but it could be extended to support more provider. So it takes that configuration file, and we'll see an example, and it creates those machines and makes sure that the Cloud Init stuff is configured correctly so that those machines will be started and configured in such a way that they can be accessed through SSH. So now we've got an example of what the Axion config looks like. So it's basically two things. First, there is the description of a provider, so how to access the place where those machines will be run. And in this instance, that's a Proxmox provider. So you've got the path to the RHEL image and the path to the CSR image, because those are the two things that Axion can provision. And then the most interesting part, which is the description of all the nodes that Axion will provision. Here you've got, it's just an example of the kind of stuff that you can do. You can decide the hardware characteristics, CPU, memory, interfaces, and you can also write files. And again, for this kind of stuff, we leverage Cloud Init, which can do all of these things. So this is another example of what a CSR looks like. It's just a different type and different configuration options, but basically it does the same. It reads that bit, and it bundles all that information in such a way that the instance will be accessible when Axion runs. So this was our way to take those big Proxmox clusters that we have, divide them into slots that could be then used by each developer to provision clusters which are full of virtual machines. So every cluster is between 6 and 9 virtual machines, depending on the options. And this tiny library that we've developed, Axion, is just a way for us to have those environments, to let developers create those environments easily to do either development or QA. So that's basically it. You've got my contact information there. The next step for us are open sourcing that bit. Again, it's not a huge library. It's just a shim, basically. So we're going to open source it in the coming months. Like I said, it has a design which lets other new users would be able to add new providers. Right now we only support Proxmox because that's the only thing that we need at the moment, but it could be extended in the future. So thank you.